Hey everyone. So as Joseph said, my name is Amr Yousef, and I'm originally an Android engineer at the app business. Today I'm going to talk about my journey in doing an architecture for my own project and why I did that. And basically I've used clean architecture, and this talk will be about how I implemented it in Flutter and how my project looks like right now in terms of architecture and what works. Mainly, we'll go, first of all, some architecture benchmarks. So we'll look into what exactly do we need out of an architecture for our project. And then we will see a quick overview of clean architecture. We'll go through how this can be done in Flutter, at least one implementation of it. We'll see how to tie in some dependency management and how this influences testing. And finally, we'll evaluate the architectures that we just discussed according to the benchmarks we started with. So first, let's go through the architecture benchmarks. And when you think about architecture, you have to think about testability. Basically, how testable is your architecture? How testable is each component in this architecture? Can you mock everything and just test what you want to test? Or are you relying on other dependencies that can make it hard for you to test your code? Second, scalability. So when you start a project, you know a set of requirements, you know a set of features. But moving on, some features change, some features get bigger, or you scale down. You might as well go from a transition where you're using Firebase as backend to use your own API and your own JSON REST API. So you want your architecture to be flexible to allow you to do this substitution easily. And you want it to be scalable, so when you add new features at it, it doesn't bloat, and it's more of the same. You want it to get boring as you grow in terms of features. Third thing is stability. So you want to test the stability of your architecture by checking how much you're relying on third-party dependencies. Let's say when you update the Flutter version that you have, do things break? When you update a library or a plugin that you use, do things break or not? Predictability, which is a big part, and basically it's a factor of testability. If your code is predictable and you can understand exactly what is the output when you give it a certain input, and you can easily map that out in your head while looking at the code, then you probably pretty much can test it. But if it gets more complicated, you don't know exactly what's happening, it's hard to test, it's hard to predict. And finally, debuggability. So you want to have a sense of idea that when someone presents you with a bug, hey, this is happening, you want to be able to understand why is it happening at each part of the architecture, is it, instead of going into a deep dive until you find some root cause. So those are what I call are the architecture benchmarks, and most of my journey to find a good architecture for my project revolved around those 5 elements. So when we look at clean architecture, first let's look at an overview. A quick overview of what is clean architecture. Again, clean architecture, as Robert Martin said it, you have some layers. This starting with enterprise business rules, which are a core layer that you can share it across different projects. It's not tied to your business logic, but it's tied to the overall enterprise. Think of it I think of it in a way that if I took these entities and put them in another project to deal with the same backend, theoretically it should work the same. On top of that, you have your use cases, which is your application business logic, which basically are the use cases that applies what the application does, what the stuff that consumes and what it outputs. And then you have interface adapters, which are your presenters or your controllers that controlling other dependencies, such as your UI layer or other frameworks and drivers that you have. So let's have a look at how we can go at it in Flutter. So if we look at the same flow, but in a Flutter perspective, we can see that in the heart of it, we can rely on models. Those models, we can call them an API model. Those are the data that you get from the API. Those are the data that you store in your Firebase storage or whatever storage you are relying on. And the data part of it is your repository implementations. So your read, write, update operations. Those are the API for this, or the contract for this, are mainly defined by your domain layer, because this is where the application and the data layer talk to each other. So it should be driven by your application business logic, and that's why you will have the interface domain layer, and underneath that you have the different implementations in your data layer, and that way you hidden the dependencies on Firebase or any third-party dependencies outside of your architecture and outside of your business logic. One thing that you need to do in your data layer is whatever data you are returning should be suitable to use in your use case or your domain layer. That means you need it to be protectable and you need to understand how it behaves, because API models gives you a certain bit of unpredictability. So for example, if we look at those two versions of a JSON file, so you might be working with an API that basically in an ideal world will give you a profile that with a blog, so you have whoever the name of the user is and the blog for them. Sometimes you don't have the blog key. If you rely on the API model that you are getting, you might get something like this. Simple class, you have string name, you have string blog. But how can you predict what the blog can be? It can be null. It can be an empty string. It's tough for you when you look at the piece of code, tough to predict exactly what you are talking, what this value would be. So we can use something like sealed unions, for example. So sealed union is a package that you can get from BubDev and allows you to specify some unions between different types and wrap them in a wrapper. So for example, in this instance, we have our optional wrapper of type T, so we can use it across any type, and that union can either be available or not available. And simply, right now, when we look at the piece of code from a domain point, from an application business logic point of view, we can see that the profile has an optional field that is a blog and that can be available or not available.
Dart's going to add non-nullable at some point.
True.
Do you think that's a better replacement when it's finally available than using options?
Of course. So in Kotlin, for example, when I'm doing Kotlin, my API models are nullable, but then when I map them and to my application business logic, they are not nullable anymore. And that's handle the safety around nullability or whatever I want in there. But as far as now, Dart doesn't have this feature, so we can replace that with sealed union, and you can do your optional type. So if we have a look again at the domain layer quickly, it's basically what applies your business logic. So let's say you have, I have a sample app, for example, for this talk that is in pieces of weather information to build a forecast and gives you the weather for today. So the domain layer would be responsible for making this business logic happen, for contacting the right APIs through repositories, mapping the data into a format that's usable across different layers, usable for me to build the state. The domain layer also has a responsibility to define what do you want out of third-party dependencies. So let's say I'm using some kind of the database, right? So say Firebase. I know I want to create, update, and delete. So I will create an interface for my repository as a wrapper for this third-party dependency. And that will give me some stability and control on what dependency I can use, and I can easily replace Firebase with whatever I want, maybe SQLite if I wanted to persist locally instead. One thing also the domain layer will have is a clear API contract on how to execute use cases and what is the results that you can get out of it. And I mean, not by results, the results are open, you can get any different data type, but again, how would that look like? How would a use case return a certain result? And the most important part of all is this domain layer doesn't contain any state. So most of your cases doesn't store any values in memory, doesn't wait for anything. It is, if you can, it's just a function that you execute it, it returns a value, and that's all about. That's all what happens there. So if we look at a simple use case, that was the forecast that I was talking about, the use case, we sort of have an execute method, and that execute method evaluates to a success or an error. Again, we are returning a type that's called a use case result. And if we have a look again, it's another sealed union, union of two. The result is either a success or a failure. And that clearly defines what you expect from every use case, how to execute them and what they are expecting. You can easily throw in a certain error type in here, for example, authentication error, if you want to pass down the 401s or 403s that you will have if you are talking to your API. And again, you can easily, for example, in here, centralize logging, so you can log at every time you get an error, which is one handy utility you can do. So if we look at the presentation layer, we can see that it's purely now about state management. You are not executing any business logic. You are just taking the result of this use case and mapping it to a UI state that your UI can understand. But first, let's have a quick look at set state and see what's wrong with it. So this is the counter example. It's simple. You have a function that mutates the state and adds 1 to it. And then every time the button is clicked, it adds 1 to the state. It executes this function. Now, the issues in here, if I want to test this, I'll have to do a UI test. And to test my state management logic, I'll have to find the button, click on it, and then that will execute the function, and then, OK, find the text and see what the value of it is all. So it makes everything not testable, not scalable. Imagine instead of you have 3 different parts of the state you're modifying, it doesn't scale well. So as we said, it's not testable. It's tightly coupled to the UI. It's very hard to test. And it makes everything not predictable because you can't understand it. While it's not scalable, you cannot predict what's happening. More states to it and more parts of the state. So options. Well, there is plenty of options right now. What we have in Flutter, you can use provider and scope model. You can use Mobix. You can use Redux. And you can use BLoC. All of this is from the Flutter documentation. It's publicly available for everyone, and most of it is open source, or all of it is open source. What I opted in using is BLoC, and basically it's a business layer container. But we'll use them in a sense that, like the reason for using them, basically, it's they're easy to do it yourself. You can use as a third-party plugin to handle everything, but you can build them yourself. It's simple. It gives you separation of concerns out of the box, so you can do the state management in one bit, and the UI will handle drawing the UI. It gives you predictable state computation, so you will know that given a certain input, you have an expected output for your state, and you know exactly when you give it an input, what is this input going to do. And everything that's stateful about your application, the stateful widgets, will become stateless, which means more performant, less build calls, easy to manage. And essentially, you can build what matters. So when you hook in the BLoC into your widget, since it became stateless, we'll use something called Stream Builder, which I'm sure everybody might know. And basically, we can build exactly part of the screen that needs rebuilding and keep the stuff that doesn't change as is. So if you have a simple BLoC, the idea is you have a stream that sends state outside. And the stream, it's a simple channel, right? You have a sender. The sender uses to pass in data to the receiver. It's as simple as that. And then that will be the stream for the state. So the BLoC is pushing outside for any listener. And then the itself is listening on the stream to fetch actions coming in to execute the business logic, to execute the state management parts of the application. So a quick example again about that forecast application that we are. For example, in here, this line shows that every time an action comes, and the action in here, by the way, is a sealed union. So we can use the join method and load whatever we want. We can also use here something called continued. And the difference is with join, you can return a data type. Continued allows you to do void functions in the middle. And basically, every time I receive a refresh action, I'll call load data. And then load data is basically pushes out a state. First of all, that's loading. It goes in to execute the use case, and then does a join on the result. And since we are returning a value, we're interested in what is the state type. So it's either an error. If I receive an error from the use case, it's ready if I receive a success from the use case. And then after all that is evaluated, we just add and push a new state through the stream. So it's pretty much predictable. You can see where your inputs are, where your outputs are, and then handling the actions becomes an implementation detail of the BLoC itself, is not exposed to other parts of your application. And finally, if we look at the UI layer, which is the most outside part of the architecture, it's all widgets. But at this point, it's stateless widgets that you can easily manage. You can easily read. It doesn't do the builds multiple times. And what you can use in here is Stream Builder. A Stream Builder is a simple idea. It's a widget provided by the Flutter framework that builds the builder block every time the stream emits a value. So our stream in here that we're listening to is a state. And every time I receive a new state, I will evaluate it using the join. And if it's ready, I'll choose a ready widget. If it's loading, I can see the progress indicator. And if it's error, I can evaluate it to the error widget. And again, it makes it, using even sealed union with the join, makes everything a bit more readable, a bit more predictable. You can evaluate the entire class without actually compiling it, just by reading it. So to tie everything up with all those layers, you need to manage the dependencies. You need to inject, basically, you need your widget relies on your BLoC, and your BLoC relies on your use case. And your use case relies on different types of classes or repositories, and you need to find a way to inject everything together. There is some requirements that we need to do when we think about all that. So first of all the streams inside the BLoC needs to be disposed properly when they're not needed. Otherwise, you'll have memory leaks, which is basically streams talking to parts of UIs that are not there anymore. Some dependencies you need to rebuild once. So let's say a use case. A use case doesn't have any state. And if I'm using it multiple times, I don't really need to build it multiple times. And some parts will have state. So let's say a BLoC that has a piece of state in it. So every time I'm using it, and I'm here talking about one-to-one relationship between the BLoC and the UI, I need to build a new instance of it. So I need to take care of that when I'm handling the dependency management and dependency providing in this part of the architecture. So again, it's very handy. You can use a sealed union to represent a dependency, right? So as we said from the requirements, we can basically say a dependency is either a singleton or an instance. And we are fairly certain that every dependency will have a type and will have a builder. That builder will be used to generate this dependency. And if we want to see how to work out that, so the singleton, basically, you can store them easily in a map typed to the object itself. And every time someone requests to get an instance, you can basically evaluate the dependency. If it's a singleton and it's already in the map, you can get it from the map. If it's not, you can use the builder to create a new instance and store it in the map for later use. And then if it's just an instance, you just use the builder to create a new instance. So where does this happen? So first of all, this happens in an inherited widget that you can call, and then that can give you this get instance. But we said as a requirement, we want to be able to dispose the streams in the BLoC. So we can pull that up into a state, inside the stateful widget, that traps the inherited widget. And that way we can use the dispose method to make sure that if I have any blocks that are singletons, or I can just cycle through them because I have stored and close and dispose all the instances there. Finally, if I want to fetch dependencies, the stateful widget will provide a get method. That get method will find the inherited widget and call an instance, which basically will use the inherited widget to get all the definitions and dependency and provide it. So how would we use something like that? For example, in my widget, basically I can make a call to the provider, and that will automatically evaluate to my homepage BLoC, and that will fetch it from where I defined it. And if I look at the definitions, it's a bit cumbersome to read, but basically you have the widget dependency providers that have a child of your home page, or your view or your widget, and you have a list of definitions. So basically every dependency you want to provide. And the trick about this in here is you can find dependencies in the same context that you are building. And technically, for example, if the remote weather repository uses this mapper, so I can use a provider context in here to fetch it while I'm building this. And that basically trickles down until you build your BLoC, and then the widget fetches down the BLoC back. So if we look at the architecture as it stands, it looks something like this. My widget uses a BLoC. The BLoC uses a use case. The use case uses one or more repositories to do its job, to do the application logic. So fairly, everything is structured. Everything is separated in its own layer. We managed to separate concerns quite well. And we managed to sort out the dependency management and the inversion of control between each layer in here. So how would we test something like this? Fairly simple at this point, because you separated the concerns pretty well. So if you want to get the widget and test it, you can mock everything from the BLoC down, and you can control the test environment for your widget. You can push the states that you need. You can take care of the actions that you need and make sure that your logic works well for drawing the UI. Same for the BLoC. So you can mock the use case, and basically, it's a result of success or error. And you can basically see your state computation logic. How is it working out for you when you are testing it, and that verifies everything. And again, you can see the use case, how it's behaving. You can mock the repository, and then you can provide you can give different, through errors, provide different values and see how the use case would behave and what the result would be at this point. Finally, you would have the implementation of each repository, and this is what you want to test separately. It doesn't depend on anything. It's architecture, so easily testable. So if we look back at the benchmarks and compare it to this architecture that we just saw, we can see that every layer in this architecture is testable. We mocked out everything. We managed to test everything in isolation quite well. We can easily add new features, since everything is separated from each other. They don't know about, every layer doesn't know the implementation detail about the other layer. So we can easily add new features or refactor old ones, because it's all implementation details after all. The big API contracts will still be the same. So it's scalable, stable, because we hidden away the third-party dependencies. So if I want to replace a plugin with another, or update a plugin with some issues, I can easily do that without affecting the entire application. Predictable, so the combination of using sealed unions and well-defined data flow. I know exactly where is my inputs and where are my outputs. And with sealed unions, it makes it a bit more readable. So it makes the architecture more predictable. And finally, debuggable, since we separated the concerns, we exactly know where everything lies. If there is an issue and we want to debug it, we can see if it's logical issue, you know exactly which layer you are talking about. And if it's runtime errors, again, you would know exactly where the error lies. That's about it. The slides, you can find it in the link there. And the sample that uses the same architecture with tests and everything can be found in here, and it will have references to the material I've used to help me tie everything up in here. Thank you.
Brilliant.
Thanks. Any questions?
Very good. Thank you. Well, hands below. I've seen yeah, sure. No.
I hear you.
So you got at the what is it called? When you stateless widget when you connect to the BLoC,
Sure.
right? Where you say
This bit.
loading as initial data. A bit further back. State to stateless.
Yeah.
This one. So here, given the fact that you're specifying the loading and also a bit lower where you join,
Sure.
a bit of dirty aspect of the clean architecture.
In terms of what?
As
What
in
makes it dirty?
The concerns, right? Here, as you build the widget,
Sure.
you are affecting the state.
Why would I be affecting the state? So
Because you're starting up in a state that now is transient to like now to change based on when the builder, the stream builder will provide you an extra state, which is not what is it called? Predictable, in a sense. Which is the whole point of this, right?
yeah, but
That's what I'm saying. Right?
no, it's a good point. But look at it that way. The UI needs to do its job, right? And you already defined the contract between the UI layer and the block that says if I give you this state, then you build me this. And who defines the state.loading part? So this is a presentation, right? So it's part of the contract between the UI and the presentation. Fair point.
That's the concern that
Sure, fair point. But it's a limitation because your UI.
I know,
Yeah.
I know, you have to be pragmatic. But
Yeah, exactly.
I'm just saying this is not ready for me.
Yeah.
In that respect.
Fair.
Interesting conversation. Hi.
Hey.
So I just wanted to ask, why did you make the dependency injection by yourself, not just something like get it or provide it?
Basically, I wanted to have a go at myself, like Get it or provider or Kiwi or any other plugin that you want. It's completely a decision for the project and for the. I like to control what I'm using and what I'm not using, and for me, to go Kiwi or go into those has a higher curve than actually building this and understanding the internals of it. So it just made sense to me to build my own, understand how it works, and then that will give me the knowledge to evaluate other third-party plugins and dependencies that I want to add.
Okay, thanks. And another question from me will be, because you talked about the unit test, right?
Sure.
And what is your strategy about integration test and end-to-end tests?
So again, everything is separated, right? So you can create a block if you want to test part of it, right? So you can, let's say you can use an actual block with a mock use case, and you can have an integration between the block and the UI only, right? You can mock the repository and test the integration between the use case and your block because you're using actual implementation between the two things. And again, you can mock the repository and then do an end-to-end test with a mocked repository up there because the repository is an implementation detail. The architecture doesn't care about where the data is coming from.
Well, if you just mock the repository in use case, that's more likely unit tests. But I was talking about end-to-end testing case, like with the real server.
Sure, but let's end-to-end test with a real server. You probably will have a test environment, right? With a mock data.
So I'm just asking how do you manage to do that? Do you have like, I don't know, the separate container and you test between it? Do you have some timeouts or how do you do that?
Yeah, I wouldn't know, to be honest, because that will heavily depend on your environment and your project from the way I see it. Mm-hmm. So I don't have an answer.
Okay, thanks.
Anybody else?
Two questions. The
Sure.
first one, in the clean architecture, from the way I understand it, the layer at the very middle, the one that Uncle Bob called entities and you called it data, doesn't really depend on any other layers. But you had repositories in that. Isn't that something that would usually be in the layer below, in the use case layer? Because the one in the middle is just your business objects with your business rules?
Well, yeah, the interfaces for the repositories or its contract is defined in the domain layer, which for me is the same as it's tied to the application business logic layer because I can have a repository that has a million things, right? But I'm only interested in 4 or 5 things. So that is driven by my business logic. So I define it there. but then data or contacting the API is an implementation detail, and that's why I have it in a data layer, and then I can use the third-party dependencies there or rely on any outside service.
Okay. The second question is have you found a way in Flutter to make sure that a layer cannot cross boundaries that it shouldn't? I know, for instance, in Java, there's stuff that's called arc unit, where you can write unit tests that say this package isn't supposed to access anything from this package.
Yeah.
And so you can make sure that you don't cross these boundaries. Is there something similar in Flutter that would tell you whether a layer reaches into something that it shouldn't?
Well, I haven't specifically found something like that in Flutter, but the way I do it is by separating every layer in its own package. And then it becomes a mental red flag if you want to go in and add this package just because you need to reference something there. So it gives you time to reflect your decision because you're doing something big here. You're linking two layers together. So my approach is separate them into packages, different packages, and then take it from there.
Okay, thank you.
Sure.
Anybody else? No more questions, really? Oh, it's a shame. All right, thank you very much.
There is a question over there.
I'm going to ask a really basic question because I'm new to Flutter. I guess
I'm new as well.
one of the advantage I can see using the stream builder is you can actually you can finally control which widget should be rebuilt rather than rebuild the whole thing.
Yeah.
So my question is, when the builder method got executed, will the framework actually repaint that widget, or it will just calculate the difference between what's currently on the screen and what's going to be on the screen, and then just render the difference, kind of like React Shadow DOM sort of way of doing it?
Yeah, that's a deep question. I don't have an answer for that. Okay. But maybe someone else in the room can give you a better action.
I believe somebody may know the answer. Simon, you look like you know the answer.
Yes.
It will rebuild that widget and everything underneath, but it does cache the widgets. So depending on how you write it, yes, it will have just the difference. So it will just sort of repaint and rebuild the difference.
Good question.
Anybody else? Interesting subject, this one. No? Okay. All right. Amr, brilliant talk. Thank you very much.
Awesome. Thank you.